Okay, Bismillahirrahmanirrahim. Today we're going to do a lesson on ordering fractions. Today's date is the okay. Don't forget whenever you do your work, we must underline our titles and our dates. Okay, we need a margin. It's all part of doing good work. Presentation is very important. Okay, let's put the next one on. Okay, so this is the sheet that we're going to be doing our questions from. There's an example there on the top. This is the sheet. So anytime you need to look at the questions, you can come back and rewind the video to this part and see what the questions are. Exercise 9, these 4 questions. Okay, let's move that to one side. Right, let's give you an example of my own. So, my name is Mr. Imran Iqbal, one-to-one tutor. We're doing this lesson today on ordering fractions. Example number 1. Let's start off with something that looks like this. Okay, so here we have just 3 fractions and we need to order the fractions, put them in order. Now because we have a third and a fifth and a half, they're all 3 different size fractions, so it's not as easy to order these as order normal numbers, because unless you know how big a third is compared to a fifth, how big 1/3 is compared to 2/5, you won't be able to tell which one's small, which one's big. So we need a method, a technique for ordering these fractions. So that method that we use is called the equivalent fractions technique. So we're going to make things in order fractions by equivalent fractions. So that's the technique we're going to use. So what we need to do, we need to look at the bottom numbers. These bottom numbers have special names in maths. They're called the denominators. Okay, so we look at the denominators and we need to find the lowest common multiple of the denominators to find out which numbers they will all go into. So if we start with the largest number first, so let's look at the multiples of 5. So we have 5, 10, 15, 20, for example. Okay, now the multiples of 3, what do we have for the multiples of 3? We have 3, 6, 9, 12, 15, 18, 21. Okay, so far the 15s are matched up. That's good. If you look at 2, we have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 21. Okay, now 5, 3, and 2 at the moment. We have what do they match in? They match in 15, but not 15 on the bottom. They match in 21 here, but not 21 on the top. Okay, so at the moment, when are they likely to match again? 5s and the 3s. 5s and the 3s will match most likely up when? So if you try some more, 25, 30. 25 and 30. 25 and 30. Now, if you look at 30, will they match up at 30? Because 30, they will all match up. They will match up here as well and here in the bottom. Okay, this is the way that you do if you're doing like an exhaustive method, a quick method. Let me show you a quick method. The same thing again. The quick technique is you just look at the biggest number and do its times tables. So 5, 10, 15, 20, 25, 30. So is the 5 also in the 3 and the 2? No. Is 10 in the 3 and the 2? No one, yes. You have 15. Is 15 in the 3? Yes. Is it in the 2s? No. 20? No. Yes. 25 and 3 is no and no, yeah, on both of them. And then we have 30. So 30 is the lowest common multiple. That's using the exhaustive technique where you write all the multiples down, trying to write, as you see, we run out of paper. This is a quicker technique, okay? Right. And another quicker technique than that. Just multiply the numbers together. So 5 times by 3 is 15 times by 2 is 30. So sometimes this will give you nice medium-sized numbers. So we have found out that the lowest common multiple of 3, 5, and 2 is, so the lowest common multiple is 30. Okay, let's move to this page here now. Okay, now, if the LCM is 30, so we need to change all the fractions into 30th, or equivalent to 30th. So let's go back to our original question. We have a third, we have 2/5, we have a half. So we know now that they can all become 30. All the bottom numbers can easily become 30. So I'm going to change color. Okay, 30. Now, how does 3 become 30? If you times the bottom by 10, what do you do to the top? Times that by 10 as well. Thank you. So 5 to 30, what do we do? Time by 6. We time the top by 6. 2 to 30. Time the bottom by and the top by. So 1 time by 10 is equal to 10. 2 times by 6 is equal to 12. And 1 time by 15 is equal to 15. So here we go. We have now converted thirds into 30ths, 2/5 into 30ths, and a half into 30ths as well. So everything is in a nice, is where we want it. We can now compare and we can see which one's small, which one's big. Well, 10 over 30 is the smallest, then 12, and then 15. So at the moment, the numbers are already in order. But when you write the answers, we must always write the answers using the original fractions. So the original fraction that 10/30 would represent is 1/3. And the one that 12/30 represents is 2/5. And the one that 15 over 30 represents is a half. Okay. Put that away. Okay, just move them out of the way, otherwise it can be a bit confusing. Get rid of that. And that. And that. It's all gone. So whenever we give the answer, we must give the answer using the original fractions. So answer using the original fractions only. Okay. Right, let's have a look at another question. Another example. If you want to go through the example again, all you have to do is just move the slider on the video and go back when you're going through your work. Okay, let's look at example number 2. Again, let's get a margin in. Let's have a look. Okay. All right. Okay, now in this question here, we have 3/4, 3/8, a half. Then we can also have 5/6. Okay. So here's our question. Example number 2. So what do we look at? In this question, we have to look at the denominators, the bottom numbers. We have to make these numbers equivalent. Okay, now, what number will they all go into? That's what we're trying to. So if we do the quick method, we do 8, 6, 4, and 2. Let's use the largest number only. So 8, 16, 24 is do for you, yeah? Now, is 8 in the 6 times table? No. Is 8 in 4 times table? Yes and yes. Is 16 in the 6 times table? No. Yes and yes. 24 in the 6 times table? Yes. Is 24 in the 4 times table? Yes. 24 in the 2 times table? Yes. So here we have our LCM. So we need to change all the fractions into 24ths, yeah, into over 24. So we found that out by just looking at the big number. The big number goes into can become 24. So can all the rest. So let's rewrite the question again over here. Let's change color. So we've got to change everything into right. How do we change into 24? Okay, so I want to change 4 into 24. I change 4 into 24 by multiplying by 6. If I multiply the bottom by 6, I have to multiply the 8 to 24, times that by 3. If I times the bottom by 3, I have to times the top by 3. 6 to 24, I have to times that by 4. And top also by 4. 2 to 24, I have to times the bottom by 12. And then the top by 12. That's what we're doing. We are now changing each fraction. We're changing quarters into 24s, eighths into 24s, sixths into 24s, and halves into 24. Once we change into 24s, we can then compare them. So let's have a look what happens. 3 times by 6 is equal to 18. 3 times by 3 is equal to 5 times by 4 is equal to, and 1 times by 12 is equal to 12. So now we can see which one's small, which one's big. So for example, we got 18 over 24, 9 over 24, 20 over 24, and 12 over 24. Okay, now, which one is the smallest number? The smallest number is going to be 9 over 24 corresponds to this fraction. So this one is the first fraction. After 9 over 24, the next biggest number is 12 over 24. So that corresponds to a half. So that will be the second. Okay, after 12, the next one we've got 18 and 20. The next one's going to be 18, which corresponds to 3/4. And so the largest fraction has to be the 20 over 24, which is 4. Okay, so the first fraction is 3/8. Remember, we do not use 9 over 24. That's just there to help us to see which is big, which is small. That's not the answer. That's just for our private. These are for our private use